Hello students, as in the last lecture, we saw the sums based on maxima and minima. As I told, the sums are from the exercise number 4.3. Your 4.2 exercise, it is based on increasing and decreasing function, but we started with the maxima and minima sums, and we completed with the first exercise. Your first exercise, it was based on how to find the equation of tangent and normal. It was based on that, how to find the equation of tangent and normal. And your second exercise, it is based on increasing and decreasing function, and the third exercise, it was based on maxima and minima. So in the last lecture we started with this sum maxima and minima. I hope you all understood the concept, as well as we took one example based on maxima and minima. We saw one example also, yes or no, in the last lecture, and I told just simply you have to follow this four step to get the answer. So let's have a quick revision of the steps, and then we'll take some more example based on this. So you will have f of x, then you will find the first derivative, then after that you will find the second derivative. And the step number 2, you will put f dash x equal to 0, where you will get a equation. Sometime the equation will be a quadratic, sometime it will be a linear, it depends on the question. Suppose if it is a quadratic, you will get two answer of x. If you are getting two answer of x, common sense, so one value turns to maximum, so second value will turns to minimum. Okay, or else vice versa. Suppose if you are getting only one value of x, so straight away either it will be maxima or it will be minimum. So there are some sums in the exercise that sometime you will get only one value of x. If you are getting only one value of x, straight away either it will be maxima or it will be minimum. Then after that, after finding the value of x, the step number 3 is what? You have to substitute this two value, x equal to a and x equal to b. So when you will put this substitute this value of x equal to a and x equal to b, see to it that you have to substitute this value in f double dash x. As I told that, just remember this three thing. You will get the value of x from first derivative. From the second derivative, you will come to know which value is maxima or minima, and exact value of maxima and minima you will get from f of x. Okay, so after getting the value of x, you will substitute the value of x in f double dash x to determine which value of x is maxima or minima. Okay, so that is your step number 3 and step number 4. It is not compulsory that in each and every sum in the step number 3 it will be maxima only, sometimes it will be minima also. Okay, so it depends on the value. And what is maxima and minima, I had explained that also. So whenever the second derivative test answer it is less than 0. What do you mean by less than 0? Means it contain negative answer. If it contain negative answers, therefore straight away you can say that if the second derivative test answer is less than 0, the function is maximum. If the second derivative test answer is greater than 0, after putting the value of x, okay, if the second derivative test answer is greater than 0 means it has the positive value. If the value is positive, straight away we can say that the function is minimum. Okay, just remember this. If it is less, function is maximum. If it is greater, the function is minimum. So these are the sub steps which you have to follow, and this all things I had explained in the last lecture. So let's check one sum, same type of sum based on this. Okay, so in exercise there are three sums. One sum based on basic algebraical, and there is one sum which is based on log part. So you must know the basic things about log properties, derivative of log. Okay, so now in this lecture we're gonna take some few example based on maxima and minima. So let's begin with the sum now. Let's check the first example. So here we have f of x, that is x cube minus 9x square plus 24x. Okay, so simply you have to follow this 3-4 step to get the answer. Okay, as we did in the last lecture. So here you have f of x. The first you will find the first derivative test with respect to x, yes or no? So what is the derivative of x cube? Derivative of x cube is what? 3x square, yes or no? Derivative of x cube is 3x square. We'll keep this minus as it is. 9 is constant, we'll keep as it is. Derivative of x square will be what? 2x using the formula of x raised to n. We'll keep this plus as it is. 24 is constant, keep as it is. And derivative of x is what? 1. I hope you all might be knowing the basic derivative. So x cube we had applied x raised to n formula. For x square also we had applied x raised to n formula, and derivative of x is what? 1. So therefore first derivative test answer is what? 3x square minus 18x plus 24. So here we got the first derivative. So now we'll find the second derivative. To find the second derivative with respect to x, we'll derivate this previous step only. We'll derivate the first derivative to get the second order test. So here we'll keep this 3 as it is. X square, apply the formula x raised to n. So this will be derivative of x square. I hope you all might be knowing, that is 2x minus 18 will keep as it is. Derivative of x is what? 1. And 24 is constant. Derivative of any constant number we know that it is 0. So in the next step, 3 2 side is 6x minus 18 one side is what? 18. So here we got f double dash x as 6x minus 18, yes or no? Okay, so here we done with the first step, step number 1. So f of x was there, we got f dash x as well as f double dash. So now we'll move on to the step number 2. We'll put f dash x equals to 0. Why we'll put f dash x equals to 0? To get the value of x. Now we'll check whether we are getting two answer or only one answer of x. So what is f dash x? F dash x, here we got 3x square minus 18x plus 24 equals to 0. Okay, as here clearly we can see that 3 is common. 3 3 6 are 18, 3 8s are 24. So if you want, you can reduce this equation and then solve the quadratic equation, or else you can solve the quadratic equation directly. As clearly we can see that the power of the variable is 2. It is a proper quadratic equation. If it is quadratic equation, of course, as I told in the last lecture, you will get two answer of x. If you are getting two answer of x, so one answer will turns to maxima and second answer will turns to minima. Okay, so now you will remove 3 as common. So inside the bracket you will get x square minus 6x plus 8 equals to 0. So therefore x square minus 6x plus 8, so 3 will go down, so 0 opening number will be 0. So as here the product is 8, so you will write minus 4 and minus 2 to get the product, as well as you will get the sum also, yes or no? Okay, so therefore in the next step what you will do, you will write x square minus 4x minus 2x plus 8 equals to 0, yes or no? After that we'll see the common. So x minus 4 you will get here, minus 2 will be the common. So inside the bracket it will be same x minus 4, yes or no? So here the one answer will be what, x minus 4, and the second answer will be what, x minus 2 equal to 0. So therefore x minus 4 equals to 0 or x minus 2 equals to 0. So therefore the first answer of x will be what, x equals to 4, and the second answer will be what, x equals to 2. As I had explained in the last lecture also, whenever a equation is a quadratic equation, you will get two answer of x. Whenever you are getting two answer of x, see to it that the one value will turns to maxima and the second value will turns to minimum, or else vice versa. Okay, it is not compulsory that the first value always it will turns to maxima only. Okay, so now to check whether x equals to 4 is maxima or minima, or x equals to 2 is maxima or minima, so simply what you have to do here, so simply you have to, so here exactly we don't know that which value will turns to maxima or minima. Okay, so now to guess, so simply we'll substitute the value of x in f double dash x to determine whether the first value is maxima or minima. Okay, so now we'll move on to the next step number 3. So for the step number 3, so first we'll take the first value for x equals to 4. Okay, for x equals to 4, so therefore we'll put the value f equals to 4 in double dash x. So here it is 6x minus 18, so therefore f double dash 4 equals to 6 into 4 minus 18. So 6 fours are, it is 24 minus 18. So 24 minus 18 is what, 6, and 6 is what, greater than 0, as 6 is positive. So 6 is what, greater than 0. So if it is greater than 0 means what, greater than 0 means what, the second order test, that means second derivative test answer after substituting the value of x is greater than 0. If it is greater than 0, so we know that the function is, minimum. If the second order test value is greater than 0, it means the function is minimum. If it is less than 0, so the function is maximum. Okay, so here we'll write f of x is minimum. So here we'll write f of x is minimum at x equals to 4. Okay, so here we come to the conclusion that x equals to 4 is what, at x equals to 4 the function is what, minimum. So of course at x equals to 2 the function will be what, maximum only. There is no doubt. So as I told that whenever you are getting two values of x, so one value, if the first value, if it turns to maximum, so second value will be minima. If first value turns to minimum, so second value of course it will be maxima. So here we come to the conclusion that at x equals to 4 the function attained minimum value. So of course at x equals to 2 it will be maximum. So now we have to find the exact value of maxima or minima. So here what you will do, here you will write, to find the exact minimum value, we'll substitute the value where in f of x. So here f of x is what, x cube minus 9x square plus 24x. Okay, so here at x equals to 4, so we'll substitute the value, we'll replace the value of x by 4. Yes or no? So your 4 cube is what, 64, 4 square is 16, 16 nines are, it is 144, and 24 fours are, it is 96. So 64 minus 144, so 80, so this will be what, minus 18. So here you will get 16. So here we got the answer 16. So here in the final step you will write the function as minimum value 16 at what? X equals to 4. So here we come to the conclusion that at x equals to 4 the function was minimum. So of course at x equals to 2 the function will be what? Maximum. So here we got the exact value of minimum also at x equals to 4, that is 16. Now we'll find the exact value at x equals to 2. So now we'll take the second value. Yes or no? The second value. So now we'll put the second value for x equals to 2. Second derivative answer is what? 6x minus 18. So therefore f double dash will replace the value of x by 2. So 6 into 2 minus 18. So 6 2 that is 12 minus 18. So 12 minus 18 is what? Minus 6, and minus 6 is what? Negative answer. So negative answer means what? It is less than 0. So f double dash. Okay, so second derivative test answer is what? Less than 0. If it is less than 0, that means the function is what? Is maximum. So here we'll write f of x is maximum at x equals to 2. As I told, whenever you are getting two answers, so one answer will turns to maximum, so second answer will be minimum, or vice versa. Okay, so here x equals to 4, here we got minimum value. So at x equals to 2, of course it has to be maximum only. So here we got x equal to 2. At x equal to 2 the function is maximum. So now if the function is maximum, so now we'll find the exact maximum answer, maximum value. To find the exact maximum value, so we'll substitute the value in f of x. So at x equals to 2, f of x is what? X cube minus 9x square plus 24x. Yes or no? We'll replace the value of x by 2. So this will be what? 2 cube minus 9 into 2 square plus 24 into 2. Okay. So your 2 cube is what? 8. 2 square is what? 4 nines are 36, and 24 twos are it is 48. So here when you will solve this part, okay, 8 minus 36 plus 48, so this will be what? 20. So here we'll write the function as maximum value 20 at x equals to 2. So that's the end of the sum. So in this way you have to present your sum in the board exam. Okay, simply you have to follow this 4 step. Okay, step number 1 is what? You will have f of x. First you will find the first derivative, then second derivative. After finding the first and second derivative, the step number 2 will be what? You will put f dash x equals to 0, where you will get the values of x. So if it is a quadratic equation, you will get two values of x. If it is a linear, you will get only one value. Whenever you have two values, so one value will turns to maxima, so second value will turns to minima, or vice versa. Whenever you are getting only one value of x in the step number 2, see to that either it will be maxima or it will be minima. So we'll move on to the next step. After that, step number 3 and 4 is what? We'll take the first and the second value, we'll put in the second derivative to check at which particular point the function is maxima or minima, and to get the exact answer of maxima and minima, we'll put the value in f of x. So that's why I told, just to remember this part, from f dash x you will get the value of x. You will put the value of x in double derivative to check whether the function is maxima or minima, and the exact value of x you will get from where? Exact value of minima and maxima you will get from where? F of x. So these are the three things you have to remember, and these are the steps which you have to follow to get the answer. So I hope you all understood the second example also, how to determine, how to guess, how to check the function is maxima or minima. Okay, so now we'll take one more example. Okay, but the pattern of the question will be little different here. So let's begin. Okay, so now let's move on to the next sum. So here we have f of x is x square plus 16 upon x. So here the pattern of the question, it is little different. Okay, before this, just focus here. For this sum, just remember this two derivative formula. So derivative of x raised to n will be what? N into x raised to n minus 1. And I hope you all might be knowing the derivative of 1 upon x will be what? Minus 1 upon x square. So just remember this two derivative formula for this sum. So it will help you all to solve the sums perfectly. Okay, so here we have f of x. So as per the rule, you will have f of x. So first you will find f dash x. To find f dash x, so derivative of x square, it is in the form of x raised to n, so derivative of x square will be what? 2x. Okay, now to find the derivative of 16 upon x, so there are two ways from which you can find your answer. So I will show the steps here. 16 upon x, we can write this as 16 into 1 upon x, yes or no? Okay, so here 16 is what? It is constant, will keep as it is, and simply we'll find the derivative of this 1 upon x, and derivative of 1 upon x, we know that it is minus 1 upon x square. So here the answer will be what? 16 up minus 16 upon x square. Okay, so now there are two ways. Once again I will explain. So this 16 upon x we can write as 16 into 1 upon x. Keep this 16 as it is, as 16 is constant, and we know that derivative of 1 upon x is what? Minus 1 upon x square. So here the answer will be minus 16 upon x square. Okay, or else this 1 upon x, we can write this as, here nothing is there, that means 1, so it will go up. So this we can write as x raised to minus 1. So we'll keep the 16 as it is. We'll apply the formula of x raised to n. So n into x raised to n minus 1. So 16 into minus 1 into x raised to 1 minus 1, and minus 1 is minus 2. So 16 into minus 1. Okay, so now this will go down. So if it is negative, so it will be what? Positive in the next step when it will go in the denominator. So here the answer will be minus 16 upon x square. So can you see here also and here also we are getting the same answer. If you do the step like this, you will get minus 16 upon x square, or else if you are changing the step little different, means if you change the flow of this step, still the answer it is same. So it is on you. Apply the direct derivative, or else first do the adjustment of this x raised to 1. So this x raised to 1 we can write as x raised to minus 1, and then apply x raised to n formula to get the answer. So it is on you. So which method you have to apply, it is on you. Okay, if you want to apply the direct derivative method, you can write the answer, or else if you want to adjust the value of x and then you have to derivate, still you can do the steps. Okay, so it is on you. So here I will stick with this method. Okay, this one. So here we'll write this plus, we'll keep this 16 as it is, and derivative of 1 upon x will be what? Minus 1 upon x square. So in the next step we'll write 2x, plus minus will be minus, and 16 upon x square. So here we got the first derivative answer. Okay, that is 2x minus 16x square. Okay, so now we'll find the second derivative. To find the second derivative, so derivative of 2x will be what? 2, yes or no? So derivative of 2x will be what? 2. So now here we'll see how to find the derivative of 16 16x square. We'll find the derivative of this part. Now we'll see how to find. So 16x square, can I add this 16 as 16 into 1 upon x square? Okay, in the next step, so can I write this 1 upon x square as x raised to minus 2? Now we'll solve this part with respect to this, because we have the derivative, ready-made derivative for 1 upon x. We don't have the derivative for 1 upon x square. Direct derivative we don't have. Okay, so to get the answer, we'll write this 1 upon x square as x raised to minus 2 to get this answer. Yes or no? Okay, so now here further we'll solve this 16 upon x square by using this method. Okay, so x square 1 upon x square will write x raised to minus 2, and this in the further next step 16 is constant, will keep as it is. We'll apply the derivative formula, that is x raised to n. So what is x raised to n? N into x raised to n minus 1. So 16 into minus 2 into x raised to minus 3, and 16 into minus 2, it is minus 32, and this will go down, so this will be what? X cube. It will become positive. Okay, so here we got the answer minus, and derivative of 16 upon x square, here we got minus 32 upon x cube. Yes or no? So in the next step this minus minus will be plus, so 32 upon x cube. So here we got the second derivative answer also. I hope you all understood how we had tracked this sum. Okay, so once again I will explain. Here you have f of x. So first you will find the first derivative. So x square, it is in the form of x raised to n, and 16 upon x, there are two methods in which you can find your answer. One is direct derivative method, or else you can write this 1 upon x as x raised to minus 1. Okay, so in both the case you will get the same answer. In the second derivative test, we took the second method. We wrote 1 upon x square as x raised to minus 2, then we had applied x raised to n formula to get the answer. I hope you all understood till here. Okay, so now after that we know that after f of x, f dash x and f double dash x, will we have to put f dash x equals to 0 to get the value of x. Okay, so now we'll see whether we are getting a quadratic equation, linear equation, or any other types of equation. Okay, so now, so f dash x is what? 2x minus 16x square equals to 0. So in the next step, can I write this as 2x equal to, will shift this minus 16 to the right hand side, so this will be 16 upon x square. Yes or no? So in the next step, this x square will go up, so this will be 2 into x square into x will be x cube equals to 16. So therefore x cube will be equals to 16 by 2. So therefore x cube will be equal to 16 by 2 is what? 8. So here we got x cube equals to 8. Okay, after that we know that taking cube root on both sides, the value of x, whatever you will get only one answer, because as per the rule, when you take cube root on both the side, you will get only one answer. When you take square root on both the side, you will get two answers of x. I hope you all might be knowing. Yes or no? When you take square root on both the side, you will get two answers of x. Whenever it is x cube, you will get only one answer. So here we got only one answer of x. Okay, so here we got only one answer of x. So x equals to 2, either it will be maxima or it will be minima. So now we'll check whether it is maxima or minima. So what we have to do, we'll take for x equals to 2, we'll substitute the value x equals to 2 where in second derivative. So what is the second derivative? That is 2 plus 32 upon x cube. So that is, we'll replace the value of x by 2, x by 2. So 2 plus 32 upon, okay, 2 cube is what? 8. 8 ones are 8 fours are. So 2 plus 4 is what? 6, and 6 is greater than 0. Yes or no? So if it is greater than 0, that means we can say that the second derivative test at x equals to 2 is greater than 0. So therefore we can say that f of x is minimum. So whenever it is greater, so whenever it is greater, so whenever it is greater, so it is minimum. Whenever it is less, so it is maximum. Okay, understood. So here we'll write f of x is minimum at x equals to 2. Okay, understood. So now we'll find the exact minimum value. To get the exact minimum value, we know that what exactly we have to do. Okay, to get the exact minimum value, we'll write here minimum value, that is f of x. So here f of x is what? X square plus 16 upon x. So at x equals to 2, we have to find the exact minimum value. So 2 square plus 16 upon 2. So 2 square is what? 4. 2 ones are 2 eights are. So 4 plus 8. So your 4 plus 8 is what? That is 12. So therefore, in the last step, we'll write what? The function f of x as minimum value 12 at x equals to 2. So in this way you have to find your answer. I hope you all understood the second sum also, and the same sum actually it is there in the exercise. It's the question number third of your question number 1. So same sum it is there in the exercise number 4.3, question number 1. It is the third sum. So in the question number 1 there are 3 sums. So we completed with the first and the third one. Now we'll take the second sum, and second sum again it is very important sum from the board point of view. Okay, so let's take the second sum now.